Hello everyone, I'm Lucian Green, and today I'd like to introduce loop2, a minimal prolog to prolog translator that converts a small supported subset of non-deterministic prolog into deterministic recursive loops. The goal of loop2 is not to replace prolog, it's to make certain prolog programs easier to understand, easier to inspect, easier to optimize, and easier to compile into other target languages. Many prolog programs use generators and backtracking. These are powerful, but can hide the actual computation. Loop2 takes a different approach. Instead of relying on non-deterministic execution, Loop2 rewrites supported patterns into explicit recursive loops. This means the resulting code becomes highly visible. You can see every step, you can see every recursive call, and you can see exactly how the output list is constructed. The philosophy behind Loop2 is simple. Generator becomes list source becomes recursive loop becomes deterministic execution. For example, suppose we have two facts, color red, color blue, and then we write a predicate that uses findAll to collect all colors. Normally Prolog executes the generator repeatedly and gathers the results. Loop2 recognizes that the colors are finite facts. It converts them into a list predicate. Then it generates a loop that recursively processes the list. The output preserves the order of results while removing the need for findAll during execution. This approach makes the generated program easier to analyze. It also makes it easier for students to understand how list processing actually works. Another important capability is member conversion. Suppose we have a findAll that iterates over a list. Instead of repeatedly calling member, Loop2 can generate a recursive predicate that walks directly through the list. This produces code that is straightforward and explicit. Every iteration is visible. Every result is produced by a clear recursive step. Loop2 also supports transformations. Imagine a list of numbers. For every number we want to compute a doubled value. Loop2 also supports transformations. Imagine a list of numbers. For every number we want to compute a doubled value. The generated code processes one element at a time. It computes the transformed value. Then it continues recursively until the entire list has been processed. One of the most interesting features is nested findAll flattening. Loop2 recognizes some of these patterns and collapses them into a single loop pipeline. Instead of generating multiple stages of collection and iteration, Loop2 can directly process the original source data. This reduces complexity, it reduces temporary structures, and it produces clearer output. Another optimization is predicate splicing. Suppose you have a simple helper predicate. The helper predicate performs a transformation on values generated elsewhere. Rather than preserving the extra predicate call, Loop2 can inline the transformation into the generated loop. This creates a more direct representation of the computation. The resulting program often becomes smaller and easier to inspect. Now let's talk about what Loop2 does not do. Loop2 is intentionally conservative. It does not attempt to preserve full Prolog semantics. It does not implement the Warren abstract machine. It does not preserve arbitrary backtracking behavior. It does not support cuts. It does not support complex control operators. It does not support assert or retract. It does not support arbitrary metacalls. Instead, unsupported programs are explicitly rejected. This is important. The system never pretends to support something that it cannot safely translate. When an unsupported construct is detected, Loop2 reports the reason. This keeps the behavior transparent and predictable. The project is designed to be educational. Students can compare the original program with the generated program. They can observe how backtracking patterns become recursion. Deterministic recursive programs are often easier to translate into C, JavaScript, WebAssembly, or other target languages. In many ways, Loop2 explores a simple but interesting question. What happens if we replace a small subset of prolog non-determinism with explicit recursive structure? The answer is that many programs become easier to visualize, easier to inspect, and easier to optimize. The project is intentionally small. It focuses on a narrow set of supported patterns, but within that space, it demonstrates useful techniques such as findAll elimination, loop generation, pipeline flattening, and predicate splicing. If you're interested in Prolog, symbolic systems, program transformation, educational compilers, or deterministic representations of logic programs, I encourage you to explore the repository. Experiment with the examples, read the generated code, and see how your own programs can be transformed into explicit recursive loops. Thank you for watching, and I hope you enjoy exploring Loop2.